The concept here is expressing vectors. Sometimes we write vectors in component form, which means x comma y. Sometimes you're given information about a vector, as here in this example, where you know the magnitude, which is like its length, and then its direction, which is the angle in which the vector is pointing. So if I wanted to visualize this vector A, I could do that recognizing theta equals 160 is in the second quadrant. And then magnitude of 12 is like its length. And so component form means I'm looking for x and y where I know that this angle theta is 160 degrees. The easiest way to get component form is simply going to be to say x equals 12 times the cosine of 160 degrees, and then y equals 12 times the sine of 160 degrees. And so I'll need my calculator to find both of those values. Quickly putting it in degree form. Sorry, I should probably have done this before the video. So 12 cosine 160, negative 11.3. 12 sine 160, 4.1. And those make sense. Y is positive, x is negative in the second quadrant. And so the final answer to the question, negative 11.3, comma, 4.1. In all instances, I'm doing magnitude times cosine of the angle for the x coordinate, and then magnitude times sine of the angle for the y coordinate. So now let's say I want to go in the other direction. Given a vector in component form, find the magnitude and direction. So I might say find the magnitude and direction of vector B, and we'll say B is negative 6 comma negative 10. I think in this instance it's almost necessary to have a picture of the vector to draw it in the right quadrant so that you can determine the theta and be certain that it's correct. Like I know right now, as I imagine my vector B, that it's got to be between 180 degrees, the direction, and 270 degrees, because vector B is pointing into the third quadrant with an x component of negative 6 and a y component of negative 10. The magnitude is just the length of the vector, and so that'll be the square root of negative 6 squared plus negative 10 squared. And so square root of 136, which is approximately 11.7. The angle is the trickier part, and I think in all instances in finding the angle and finding the direction for a vector, find the reference angle and then use the reference angle and your picture to get the direction appropriately. And so what I mean by that here, I'm going to take this triangle and say that side's 10, that side's 6. I'm just looking at the right triangle, so I don't care about pluses and minuses. I'm looking for this angle, the reference angle. And what I know is that the tangent of the reference angle is opposite 10 over adjacent 6. And so the measure of the reference angle is going to be the inverse tangent of 10 over 6, which now I use my calculator and get 59 degrees. So this right here is 59 degrees. What I'm looking for the direction of the vector is this whole angle. And so what I'm going to recognize as theta is, in this instance, because the vector is in the third quadrant, 180 degrees plus the reference angle, 59 degrees, equals 239 degrees. If I always draw the right triangle, ignoring the pluses and minuses, I can find the reference angle and then use that to calculate the theta.